Visualizing audio in Godot, how it's done, and why you may want to do it for your own games. I'll be briefly going over why and how I did it, and the potential use cases I've been thinking of for game dev. If it's your first time here, I'm a data engineer learning the ropes of indie game dev to one day get my own game up on Steam. If you enjoyed, then subscribe to follow my progress, and possibly inspire you to start your own game dev journey. Now, as you can see on screen, I've been using this part of the voice recording to demonstrate a basic way to visualize speech audio in Godot. Seeing this, I'm sure you can think of many ways this could be used. For instance, adding lip syncing to NPCs and other cool things like that. What inspired me to look into audio visualizing in Godot was my recent playthrough of the rhythm-based RPG EverHood. For fans out there, I'm sure I don't need to say much more about how great this game is, but if you haven't played it before, then I would highly recommend it. For some reason, another game that came to mind as I was playing EverHood was the Nintendo DS game Elite Beat Agents, another top-tier rhythm game from my childhood. Both of these games uniquely visualize audio as a way to create battle mechanics for their respective games. Elite Beat Agents with its more traditional rhythm game mechanics of timing beats, and EverHood with the way the music syncs the enemy's attacks. With a bit of a passion for music creation in general, I definitely wanted to put more thought into the potential mechanics I could add to my own game that incorporated audio visualization in some way. Now, let's go over the basic method of capturing audio frequencies in Godot so that we can use them however we like. I'll show a basic visualization using this method and a few examples, including the one I used to visualize my voice at the start of the video. I'll also be sharing the code used in the GitHub with a link in the description if you wanted to check it out yourself. First off, we need a scene to work in. For my examples, I created control nodes to store the visualizer script in, but you could technically use any node depending on how you want to utilize the frequencies. Next, in order to keep the audio in its own bus, so we aren't analyzing every sound in the game, and only the sound we want to analyze, we create our own bus and name it something like Visualizer. Then we have to make sure to add the Audio Effect Spectrum Analyzer. This effect allows us to analyze the frequencies of the audio in this bus. And all we have to do in our control node script is have access to the audio stream player and assign whatever audio we want to analyze. One important thing to note is for the audio stream player, we have to set the bus to the one that we just created. Then we can go ahead and write the rest of the script. I'll just be demonstrating the script for the basic bars, as the circular one gets quite a bit more complicated since it involves creating curved lines and using specific algorithms. So first we need a reference to the audio stream player, and then the main sauce of this method is to grab a reference to the Audio Effect Spectrum Analyzer effect that we added to the audio bus earlier. We do it like so, by referencing the index to the bus and the index of the effect, which is 0 since it's the first effect of the bus. The only function that this effect gives us is access to the getMagnitude for frequency range function. Basically, this returns a vector2 object that we can get the length of using the length function. This returns the maximum frequency magnitude observed in the frequency range that you provided and returns it as a float value. This is what we need because now we have a tangible piece of data we can use in any way we want. So in essence, what I'm doing for this bar sound creation is every bar represents a certain frequency range, and every time process is called, I'm updating the length of the bar based on the magnitude of the specific bar's frequency range. And that's basically it. For the technical details and how to create the bars and stuff, you can look at the GitHub repo or ask me questions in the comments. For the circular example, it's pretty much the same thing, except the bar ranges go around in a circular shape, and I can also shuffle the bars for a more dramatic effect. Another thing to note is that the magnitude value returned is very small, so I usually multiply it by at least 1,000 in my scripts. All in all, I've started to experiment with using these magnitudes to create enemy attack patterns like in the rhythm games I mentioned. Alright, that's it for today's video. It's a bit of a shorter one today, but I hope you enjoyed it. Again, the code is in the link in the description, and if you have any questions, leave a comment. I hope you all have a great day.